Okay, we want to find the intervals where this function is concave up, down, and inflection points. So we need to start by finding the second derivative to find potential inflection points. So the first derivative, bringing down the 5, we get 15 t to the 4th minus, let's see, 35 times 4. If you need to use your calculator for big numbers, that's okay. That's not too super big. 35 times 4, it says, is 140. So minus 140. Oops, there we go. Minus 140 t cubed plus 300 t squared. Okay, the derivative of 100 is 0. So now g double prime, we're going to take the derivative of that one. 15 times 4 is 60 t cubed minus, let's see, 140 times 3. Well, that's weird. Oh, apparently I didn't hit 3. 140 times 3. There we go. It's 420 t squared plus 600 t to the first. Okay, so that exists everywhere, so we're going to find where does it equal 0. Let's see if I can take a 60 out of everything. If I do 420 divided by 60, yeah, we should get 7 exactly, because 42 divided by 6 is 7. So I can take a 60 out of everything. So 60, I can also take a t out of everything. So leave me with t squared minus 7t plus 10. That's it. Okay, now I'm going to keep factoring, and I'm going to continue to write all of it. Well, let's see if we can keep factoring. Well, it looks like if we do t minus 5 and t minus 2, that should work just fine. Okay, that's my fully factored version of the second derivative, so let's circle that. Then setting each of those 3 factors equal to 0, don't forget this one, that's a factor 2. We're going to get, I'm going to do this in my head, we're going to get 0, 5, and 2. Those are possible inflection points. Now we want to find concavity, so I want to put those numbers on a number line and order those, 0, 2, and 5. Okay, and that splits up our x-axis like this into 4 pieces. Okay, so we need to plug into the second derivative. I'm going to pop that factored version because I'm going to plug into that. So let's do g double prime of any test value in that interval. So I'll go with -1. Let's see, that would give me a negative factor here, a negative factor there, and a negative factor there. So negative times a negative times a negative is negative g double prime of 1. And by the way, you need to write all this out so that I know exactly what you're doing. Okay, g double prime of 1 is going to be positive. 1 minus 4 is negative. 1 minus 2 is also negative. So positive times a negative is positive. And 2 to 5. How about g double prime of 3? So that would be positive, negative, and positive. So negative, and g double prime of 6 would be positive, positive, and positive. Okay, so g is, so that's negative, so concave down, concave up, concave down, and concave up. Okay, so it's concave down, there, and there, and concave up, there, and there. So let's look at this. Let's see, it's concave up from, what did I say, 0 to 2, and 5 to infinity, 0 to 2, and 5 to 2 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 negative infinity to 0, and 2 to 5. Okay, so where are the inflection points? Everywhere where it changes. So actually it changed at all three of those x values, so 0 or t values, so 0, 2, and